Hello, Pre-Calc Honors kids. We are going to start today's lesson with an opener from 5.1. This has been sent to your OneNote, and you are to find all solutions in radians for the given trig equations. I want you to go find this document, and I want you to work through problem 1 and problem 1 only, and then come back and we'll work through that together. Okay, at this point in time, you should have worked through problem 1. And so I'm going to quickly work through this with you just to check your work. We have to factor, and so as I've stated before, if you need to do some type of substitution method, feel free to. I am not going to show a substitution method. However, if you want to join in any of my live sessions, we can work through that. Okay, so I believe I have this factored properly. And now we're going to set each factor equal to 0. And so now we have to figure out when cosecant equals 1 and when it can equal 2. This means that we have to understand what the cosecant's relationship to sine, and it is the reciprocal. So I don't have the final answer here yet. I just know that sine is 1 at pi over 2, and the reciprocal of 1 is 1. So I have x equals pi over 2, and then I have to add on that plus 2 pi k. And for this entire document, we're going to assume k equals an integer. Sine is positive in quadrants 1 and 2, and so we're thinking about when sine is 1/2, since it's the reciprocal of cosecant. And once again, we're just going to go ahead and add that on. I want you to pause the video and do problem 2. One of the biggest mistakes made at this point in time is that students will divide through by cotangent, which will eliminate some of their solutions. That means you have a GCF. So let's go ahead and get this set equal to 0. Okay. Now I'm going to factor out this GCF. And then I'm going to set each factor equal to 0. Again, at this point in time, I know I'm moving pretty fast, but you should have taken that opportunity to work through this on your own prior to watching the video. Here's where I'm at. So I have to think about when cotangent is 0 and when cotangent x is 1 over root 3. So cotangent, there's a couple ways students look at this. They think about the identity that cotangent is cosine over sine. And so we have to think about when cosine is 0, or students think about their triangles. They think about their special right triangles. And so you might want to think about a 30, 60, 90 to help you with this guy here. So cotangent is going to be 0 at pi over 2. However, it's going to be 0 again at 3 pi over 2, so I don't have to write two equations. I could go ahead and write that as x equals pi over 2 plus pi k. So cotangent x equaling 1 over root 3. So if I think about a 30, 60, 90 triangle, this is x root 3, and this is 2x. And essentially, to get 1 over root 3, I'm going to need to think about x over root 3. Cotangent is the side adjacent over the side opposite. Okay. So if I use 60 degrees, cotangent of 60 degrees, for example, equals x over x root 3. And that helps me there. I know cotangent is positive in two quadrants, quadrants 1 and quadrant 3. So in quadrant 1, a 60-degree angle. And I'm going to erase my triangle to kind of move that out of my way, is pi over 3. But it's going to be 60 degrees again. I'm sorry, positive again using a 60-degree reference angle in pi, in 180 degrees. So I can write this like this. So every pi k. And there you go. We have one more problem to go. I'm just want you to pause the video, but I want to give you a hint before you go and try this one. If I go ahead, let me get a different color. This makes me happy. I'm going to act as though I'm moving it to the right. I again, it's my thing. I like that positive leading coefficient. And so I move that over properly. But my issue is I do not have a GCF. I have this trinomial, but I've got an issue. I want them to be the same. I want them to either be sine or I want them to be cosine. So I want you to think about your trig identities. You're going to have to replace something. And I want you just to do one step here. I want you to think about which trig identity you're going to use and how you're going to replace it. So if you recognize the fact that sine squared x needed to be replaced by 1 minus cosine squared x, you understood it. Great. At this point in time, please pause the video and finish the problem. Okay, so I've worked through this problem up into the point where I have to write up my solutions. So take a moment, look through my work, even if it means you have to pause the video. So cosine x is positive in quadrant 1 and 4. So I want to talk about the different ways to write that up. So let's first take cosine x is 1/2 at a 60-degree reference angle. And I could write this way. Okay, and I could say this. Or the unique thing about cosine is the fact, if you look what I'm drawing, the angle's either going to be here or it's going to be here, and they're equidistant away from that x-axis. So I could have written this as x equals plus or minus pi over 3 plus 2 pi k. That works. Cosine x equals -1. Cosine x will be -1 at pi, and it will happen every 2 pi k. I hope you're all doing well. Please join in a live session if you have any questions.